Good day. We are the group Ain't Showy, and we are here today to discuss the topic descriptive statistic. Under of this, we can learn the mean, median, mode, mid-range, range, standard deviation, variance, and percentile.
Mean. A statistic or parameter equal to the sum of all data points over the number of data points. How to determine the mean? First, you need to arrange the given data set from lowest to highest. The example 4, 3, 14, 7, 9, and 16. Arrange it from lowest to highest goes to 3, 4, 7, 9, 14, and 16. Then add up all the numbers, then divide by how many numbers there are. In other words, it is the sum divided by the count. 3 plus 4 plus 7 plus 9 plus 14 plus 16 is equal to 53. Then 53 divided 6 is equal to 8.83. Therefore, the mean of the dataset is 8.83. A statistic or parameter that represents the middle value when data points are arranged in increasing or decreasing order. Calculating the median. If the number of the data points n or n is an odd number, then the median is the middle value. Example, 3, 4, 7, 8, 9, 14, 16. The middle value of the dataset is 8. Therefore, 8 is the median. And then, if the number of the data points is an even number, then the median is the average of the two middle values. Example, 3, 4, 7, 8, 9, 14, 16, and 20. The middle value of the dataset is 8 and 9. Then get the average of the two value, which is 8.5. Therefore, the median is 8.5.
Now, we were discussing the mode. First, what is mode? A statistic or parameter that represent the data point with highest frequency in set. There are 5 types of mode: the unimodal, bimodal, trimodal, multimodal, and non-modal. Unimodal has only one mode. An example is set A is equal to subset of 1, 3, 5, 6, 1, and 9. This is unimodal because there is only one number that repeated and it was 1. Bimodal has two modes. The example is set B is equal to the subset of 1, 1, 3, 8, 7, 6, 9, 9. It was bimodal because there are two numbers that repeated and it was 1 and 9. Trimodal has three modes and our example is set C is equal to subset of 2, 2, 2, 3, 4, 4, 5, 6, 5, 4, 7, 5, 8. And it was trimodal because there are three numbers that repeated: the 2, the 4, and the 5. Multimodal has 4 or more modes. Our example is set D is equal to the subset of 1, 1, 1, 1, 2, 3, 6, 7, 7, 7, 7, 8, 8, 8, 8, 9, 9, 9, 9. And it was multimodal because there are 4 numbers that repeated frequency at 4. These are 1, 7, 8, and 9. And last is non-modal, has no mode. Example is set E, the subset of 1, 2, 3, 4, 5. It has no mode. There is no number that repeated. Our next topic is mid-range. Mid-range is a statistic or parameter equal to the average of the lowest and highest data point in set, meaning it was the lowest and highest added divide 2. We have example here. The subset of 14, 54, 32, 33, 5, 6, 13, 20, 10, 44. First, we get the highest number is 54 and the lowest is 5. Then we add it and we will get the answer 59. After that, we divide it in 2 and the answer will be 29.5. Therefore, our mid-range is 29.5.
Range, a statistics or parameter equal to the highest value minus lowest value in the dataset. Example, set of 14, 54, 32, 33, 5, 6, 13, 20, 10, and 14. First, get the highest value and lowest value, which is highest is equal to 54 and the lowest is equal to 5. Second, subtract the two values, which is 54 minus 5, and it is equal to 49. Then, divide the answer by 2. It is 49 divided by 2, and it is equal to 24.5. Therefore, the range is equivalent to 24.5.
In statistics, the standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that have values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. Example, 23, 14, and 25. First, solve for the mean. X equals 23 plus 14 plus 25 equals 62 divided by 3 equals 20.67. S equals the square root of summation of x minus x squared divided n minus 1. S equals the square root of 23 minus 20.67 squared plus 14 minus 20.67 squared plus 25 minus 20.67 squared divide 3 minus 1. S equals 5.86.
Variance. The variance is defined as the average of squared distance from each point to the mean. How to calculate variance? Is represented by S squared. S represents sample standard deviation, but S squared is the variance of a sample and it is equal to the sum of square difference between each data point and sample mean represented by variable x bar divided by v minus 1, where n is the size of the sample. Now, let's calculate the variance. Given these data numbers 3, 4, 5, we need to list the data in ascendant order. Now we can calculate the sample mean. The sample mean is basically the average is equal to the sum represented by sigma symbol. The sum of all the data points divided by the number of data points that we have. The sample size and our sample mean is 4. We're going to subtract each data point by 4. Now, what we're going to do next is going to take the square of those difference. The square of the difference must be positive. Variance is going to be the sum of the square difference between each data point and the sample mean divided by n minus 1. So to get this part of the formula, we simply need to take the sum of the last column divided by n minus 1. The answer is 1 and this is the variance of the sample. Percentile. If a data point in the kth percentile, then k% of the data points is smaller than this. We have example here, and we need to find the 74th percentile for the following data, where we let k equal to the kth term percentile, which in our case, because we are looking for the 74th percentile, k is equal to 74. I is equal to the index, what is also referred to as the ranking of position of given data value, and n is equal to the total number of data values. Because we have 23 data values, n is equal to 23, and now to find the 74th percentile, the first step is to order the data from least to greatest. In our case, though looking at the table, the data values are already in order from least to greatest in rows. Step 2, we calculate which is equal to k divided by 100 times to the quantity n plus 1. So we substitute I is equal to k divided by 100 is 74 divided by 100, and then times to the quantity n plus 1, which in our case give us the quantity 23 plus 1. Simplifying, 74 divided by 100 is equal to 0.74. 23 plus 1 is equal to 24. And this product is equal to 17.76. Now we know I is equal to 17.76. Next, if I is an integer, then the kth percentile is the data value in the ith position. But in our case, I is 17.76, which is not integer, and therefore this does not apply. If I is not an integer, then we round I up and round I down to the nearest integer, and then we average the data values in those two positions. So if we round I down to the nearest integer, which we call as I sub down, we have 17. If we round I up to the nearest integer, which we'll call I sub up, we would have 18, which means the 74 percentile is equal to the average of two data values in 17 and 18 position. So going back over to the table, we have 5, 10, 15, 70 is in the 16th position, and therefore 82 is in the 17th position, and 84 is in 18th position, which means the 74th percentile is the average of these two data values, which means P sub 74, the 74th percentile, is equal to the quantity 82 plus 84 divided by 2, which is equal to 83. The 74th percentile is equal to 83. And remember, 74% of the data values are less than or equal to the 74th percentile, which means in our case, 74% of the data values are less than or equal to 83. Thank you for watching, and this is our group, the Ain't Showy, JV Miranda, Uriel Romero, Aidan Jeho Montoya, Jasper Kurt Dizon, Aaron Joseph Pangilinan, Kyle Ivan Cueva. Thank you.